So we'll begin with carboxylic acids and esters. So carboxylic acids, like we just saw, is another functional group which is RCOOH. You could expand this as RC double bond OH. So this is a derivative of the carbonyl group. When you have a carbonyl group attached to another hydroxy group, that makes it carboxylic acid. So it has a carbonyl group and it has a hydroxyl group. Okay, these are basically acids, carboxylic acids. So you see the name has an acid into it, which means these are the organic acids. So up until now we have seen acids like HCl, H2SO4, hydrochloric acid, sulfuric acid. Those are inorganic acids. These are organic acids. They are carboxylic acid. They have to have this group RC double bond OH. This makes anything a carboxylic acid.
You're saying HCl is inorganic?
HCl is an inorganic acid. So anything else outside of the carbon and hydrogens groups are basically inorganic, regarded as inorganic. Right? HCl, H3PO4, H2SO4. Okay, those are all inorganic acids. Okay. Next, how do you name these carboxylic acids? So basically you name the alkane and replace the E with oic acid. That would be name of a carboxylic acid. So for instance, what would be the smallest acid possible? 1 carbon. How would you make 1 carbon acid? 1 carbon, and it has to have, since it's an acid, it has to have this group, right? COOH. And how many more hands can this carbon make? It has 1, 2, 3. It already has 3 bonds. It can make 1 more. So 1 more hydrogen.
Why would it be hydrogen though? Oh, because
it's 1 carbon. So because it's a 1 carbon acid, this carbon is already counted. The carboxylate has a carbon, right? This acid, this group has 1 carbon into it. So if you add another carbon, that's 2 carbon compounds. So you would add another hydrogen. So this is the smallest carboxylic acid which is possible. What would be the name? 1 carbon, if this was alkane, 1 carbon would be methane. But in this case, instead of having it, we would replace this E with oic acid. So it would become methanoic acid. Okay. 2 carbons. If I were to draw true carbon acid, 2 carbon would be, you draw 2 carbons. It's an acid, so it has to have the COOH group. So one of these has to be the COOH. And how about now we add hydrogens. How many hydrogen does this carbon need?
That one?
Yeah, none.
It has 3 bonds, so it has 1.
It has 1, 2, 3, 4 bonds.
Yeah, I mean,
So
it
doesn't need any hydrogen. How about this?
It has 1 bond, so it needs 3.
Perfect. So that would be the 2 carbon acid. How would you name it? You would, again, when you're naming the acids, you would include this carbon. Okay, and this carbon would be regarded as your number 1 carbon. This is given the preference now, because this is your functional group. Functional groups are given the preference. So this is carbon 1, this is carbon 2. 2 carbon means ethane, but instead of ene, it would be oic acid. So it would be ethanoic acid. Okay, and now you could simply add a substituent wherever you want. Simply name the alkane first and then replace the E with oic acid. So that would be always your part of parent chain. So whenever you see this COOH, that would be part of your parent chain. Okay. So for instance, if I were to name these, how would we name? Let's start with the first one, which is right here. How would we name the first one? First thing you see when you see a molecule, this, what is the functional group on this molecule?
It's going to be
COOH. Yeah, you're right, it's butanoic, but let's go step by step for now. So this is an acid group. How do you name acids? You basically, this is your functional group, you start numbering from here. So this is 1, 2, 3, you could go straight, that would give this 4, or you could go up, that would make this 4. So the longest chain either way is 4 carbons. So 4 carbon means the parent chain is called butane, and in this case it's an oic acid, so it would be butanoic acid. Perfect. This is butanoic. Again, sorry, there would be a space here. Butanoic acid.
Would you like by methyl? I mean methyl?
Methyl.
Or methyl?
Which carbon is the methyl? This is the substituent. This is methyl. Which carbon is it on?
3.
Third carbon. Perfect. So this would be 3-methyl butanoic acid. Okay. How about this? This, whenever you see something like this is a benzene ring. So now you need to add this to your list. Whenever you have a benzene with a COOH group. This is perfect. This is called benzenoic acid. Okay. Now this is always benzenoic. Now you have to add substituents. So in this case, what is my longest chain? This would be regarded as my parent chain. It's not like a longest chain, but it is my parent chain because this is part of the, it's not part of the ring, but this is part of this name already, benzoic acid. So now we have two substituents. Where are they located? We have to number those.
Yeah.
Where would I start numbering?
First carbon.
This would be given the preference. This will not be counted in. Okay, this is out of the benzene ring. So benzene is what we count. When we say benzoic acid, we have already added one carbon to it. So this is already accounted for. We are not going to count it in. So this would be 1, 2, 3. I could go the other way, but I would not because that would give my substituents a very bigger number. So we go this way. So now my substituents are 2 chloro, perfect, 2, 3 chloro and 3 chloro. How do we name it? We would say 2,3 dichloro benzenoic acid. Perfect. Okay, good. So that is how you name your carboxylic acid. You simply name the alkane just normally how you would, and instead of E, you put oic acid. Okay. Now again, you can see some of the acids right here. This is the 1 carbon acid. You would draw it like this. This means every corner means a carbon, right? So it only has 1 carbon corner right here, so that would be carbon. 1 carbon acid would be methanoic acid. 2 carbon, 1 and 2 would be ethanoic. 1, 2, 3 propanoic. 1, 2, 3, 4 butanoic. Just remember that you do have to count this carbon in the, when you're counting the longest chain. This is part of your chain. Okay. Now again, we have seen some common names for these, right? So we saw that when it is 1 carbon, it is called form, right? So in this case, it is called formic acid. When it is 2 carbon, the common name was acet. It is called acetic acid. When it is 3 carbon, it was called propion, so it would be propionic acid. 4 carbon was butyr, so it would be butyric acid. Again, I don't expect you to memorize these names, but when it comes in front of you, sometimes you should be able to recognize that this is, okay, this is acetic acid, so it probably is 2 carbon acid. Okay, form is for 1 carbon. All right, already done. So let's try naming these. So the first one, again, you first have to identify what functional group do you see. See an acid. So now I name it like an acid, which would be oic acid. How many carbons? 1, 2. Again, you could go up, that would give you 3. You could go straight, that would give you 3. So this is my longest chain. So 3 carbons would be propanoic acid. Perfect. So that's my parent chain. Now I need to name my substituents, which is right here, which is perfect. It is 2-methyl. So answer is 2-methyl propanoic acid. Then we have this compound B. What you see right here is the benzene with a carboxylate group. So this would be benzenoic or benzoic. Yeah. Benzoic acid. And what is the group? we see bromo is my substituent. Where is it located?
Third.
Perfect. 1, 2, 3, third carbon. So this would be 3-bromo benzoic acid. Okay. Okay, then the next question is asking you to draw the line angle formula for 4-chlorohexanoic acid. So whenever the name is given, we start from the end. It's oic acid, so it is carboxylate. I have to have a COOH group. Hexanoic, so hex means 6 carbon. I start with 1, 2, 3, 4, 5, 6 carbon. 1, 2, 3, 4, 5, 6. One of those is carboxylate. Remember, carboxylate is a part of those 6 carbon. So you simply can draw an OH and a double bond O. And it has to be terminal because you can't draw, this carbon cannot have a double bond O and an OH. It's not possible because that would make it 5 bonds. That's not possible. Okay, so this is hexanoic acid. 4-chloro, oops. Okay, so we skipped it. So now how we start naming? 1, 2, 3, 4, 5, 6. And 4th carbon has a chloro, so I draw chloro right here. So that would be our 4-chlorohexanoic acid. Okay, now let's talk about some properties of carboxylic acids. So what do you think, carboxylic acids would be polar or non-polar? The polar groups in organic chemistry that you have seen up until now was an OH group is a polar group and a carbonyl group is a polar group, right? And what does a carboxylic acid consist of? It contains both the groups. So that means this is a polar compound. That would make this a very polar compound. They are strongly polar because they consist of 2 polar groups, hydroxyl and carbonyl together. So in this case, what would happen? The carbonyl group, the oxygen would have a partial negative charge and the carbon would have a partial positive charge. And hydrogen will have a partial positive charge, oxygen will have a partial negative charge. Remember, oxygen is an electronegative compound, an atom, so it always carries a partial negative charge. Okay, so when we talk about an acid, for instance, this is propanoic, 1, 2, 3, propanoic acid. It is polar because it has carbonyl group, which is polar, hydroxyl group, which is polar. And why is this so important? This is important because it can make bunch of hydrogen bonds now. So if you think about this can make a hydrogen bond with something else. This oxygen can make a hydrogen bond with something else, right? So how can they make a hydrogen bond? For instance, if I draw this acid, let's say I draw CH3, CH2, I have a C double bond O, and we have an OH group right here. Okay, so you could have another carboxylate group which has COH. Yep, perfect. So this hydrogen has a partial positive charge. This oxygen has a partial negative. This oxygen has a partial negative. This hydrogen can form a hydrogen bond with this oxygen.
But I have a good question. So you said for the
Only a force of attraction because of the electrostatic charges. So it is not really a bond. So oxygen doesn't have to get rid of any of the bonds. This is simply a force of attraction between hydrogen and oxygen just because of the charge. Just an electrostatic attraction. That's it. No, it's called a hydrogen bond, but it's not really a bond. It is just equally strong, not really equally strong, but it is very strong compared to other force of attraction. Okay. And how about this? Same thing applies here. This oxygen has a partial negative. This hydrogen has a partial positive. This oxygen has a partial negative. So this hydrogen can form a hydrogen bond with carbonyl. So you can see only 2 carboxylic acids can basically make 2 hydrogen bonds with each other. So sometimes these carboxylic acids can form dimers. Like this looks like a dimer now. What is a dimer? 2 monomers coming together. Monomer means one compound, one unit. So here the same carboxylic acid has come together twice and formed a new compound. It's not really a new compound, but it's the same compound, but it is closely attached to each other.
So it's like kind of making, like, it's like 2 drops of water.
Yeah, they're just attracted towards each
Make
other.
it bigger.
Yeah, so it's the same compound. It's not chemically, it's not anything different. It's just very strongly attracted towards each other. So basically they have very strong intermolecular force. So if you need to break this intermolecular force, you have to give it a lot more energy, which means they would have a lot higher melting point or boiling point. Because in order to melt something, you need to get rid of these intermolecular forces. In order to boil something, you need to get rid of these intermolecular forces. So because this force of attraction is so strong, you need more energy to break this force of interaction. And therefore the melting and boiling point would be higher.
How will you continue this chain then? Instead of like it can't bond anymore, right? Because
Yeah, because now this oxygen is available.
Oh.
This is also partial negative, so it can form another interaction, right? And this oxygen also has lone pairs. If you draw the Lewis structure, this has 2 lone pairs. So one lone pair is here, the other lone pair can also interact with another hydrogen, right? So essentially it's a chain. It would be a bunch of hydrogen bonds that can be formed within this molecule. So the intermolecular forces essentially increase. Okay? Can even form hydrogen bonding with water. We'll talk about that in a bit. But basically, this tells you that this allows the carboxylic acid to form multiple hydrogen bonds with other carboxylic acid molecules. And therefore, their boiling point, melting point would be a lot higher in comparison to aldehydes or alkanes or alcohols. Okay, so if you remember, aldehydes have a carbonyl group, alcohols have a hydroxyl group, carboxylic acid have both the groups. So when we talk about their boiling point, which group is the least polar out of these? Carbonyl. So aldehyde will have the least melting or boiling point, then it would be alcohols, then the highest boiling point would be carboxylic acid, because it will make twice the amount of hydrogen bonds because it has both carbonyl and hydroxyl group. So you can see right here, this is 3 carbon aldehyde, 3 carbon alcohol, 3 carbon or 2 carbon carboxylic acid. So if you're comparing those, acid will always have the highest boiling point. Okay, so for instance, like I just showed you, carboxylic acid right here can form 2 hydrogen bonds with each other and they would form a dimer. So 2 carboxylic acid molecules can interact with each other, and that is why 2 hydrogen bonds between 2 carboxyl groups, which effectively double the mass of the molecule, increasing the temperature required to reach the boiling point. So it requires even more energy to break these force of attractions. Okay, for instance, a question could look like this. Match each of the compounds 2-butanol, pentane and propanoic acid with the boiling points. So boiling points are given, one is 141, 100, 36. So essentially it's just asking you arrange them in an increasing or decreasing order, right? So we have an alcohol, pentane, which is alkane, and propanoic acid. So the question is telling you they have the same molar mass. Molar mass is similar means the effect of molar mass is negligible now, right? So you only have to arrange it based on the groups that you see. So which group forms the most hydrogen bond?
It would be propanoic acid.
Perfect. So acid will form the most. So this should have the highest boiling point, which is out of this 141. So I would assign this the highest boiling point, which is 141 degrees Celsius. Then we have alcohol, because alcohol has another OH group which is also polar, which will also form hydrogen bond. So the next would be this, and pentane is a completely non-polar molecule. It has no force of attraction, or the only force of attraction it has is dispersion force. There are no polar molecules, there is no hydrogen bond, so this would have the lowest boiling point, which means they are going to boil much faster because there's no forces keeping it together, keeping the molecules together. So therefore this is the least temperature. And that's your arrangement. Okay. Then we talk about solubility of carboxylic acids in water. Like we discussed, when are things soluble in water? When they can interact with water. Water is polar, you need something polar, and they have to make some force of, there has to be a force of attraction between water and the molecule, then it will be soluble in water. So in this case, carboxylic acid can form hydrogen bonds, water can form hydrogen bonds, so basically they both can form hydrogen bond with each other, and that would make carboxylic acid soluble in water. Okay, so how would they form carboxylic acid? So if this is carboxylic, this is carbon. Let me choose another color. So this is carbon, this is oxygen, and this is oxygen, this is hydrogen. So this is COOH group of carboxylic acid. Water is right here. This is oxygen, this is hydrogen, and hydrogen of water. Hydrogens are partial positive. Oxygen is partial negative. Similarly, this oxygen is partial negative, this carbon is partial positive. So they are going to form a hydrogen bond with water. So simply you can see one carboxylic acid, this is one carboxylic acid. It can form hydrogen bond with so many water molecules. One water molecule can come right here, because again oxygen has two lone pairs. So it can form two hydrogen bonds. Same thing, this oxygen can form hydrogen bond with two more. And this hydrogen which is bonded to the O, which is the OH group, can form hydrogen bond with the oxygen of water, right? So basically one carboxylic acid can form so many hydrogen bonds. It can form 5 hydrogen bonds with 5 different water molecules. And therefore this increases the polarity and the solubility in water. Okay? But which again, when you increase this is the only group that is polar, right? Carboxylate group. This is the only group that makes it polar, where if you increase this chain, which is the alkyl chain next to it, it will increase the non-polarity of this molecule, right? So the carboxylic acids with 1 to 5 carbon atoms are very soluble in water. So 1 to 5 carbon, but if you increase more than that, it becomes less soluble, and if you go higher, it becomes insoluble.
What was the thing yesterday for 4 more carbons?
So as the number of carbon increases, the solubility of the carboxylic acid in water reduces or decreases. So you can see right here, 5 carbon is soluble. When you go to 6 carbon, it becomes slightly soluble, and anything more than that is, you could regard it as very sparingly or insoluble, right? And same thing with benzoic acid. Benzoic acid is also 6 carbons, so this is also slightly soluble, right? 6 carbon chain, total it's like 7 carbon, but this is one carboxylate keeping the 6 carbons together, trying to make it soluble, so it is only slightly soluble. Okay. Next we'll talk about another property of carboxylic acids, which is acidity. We are saying that these are acids. Acids carry some acidity. Acids are something that donate a proton, right? What is the definition of an acid? Acid donates proton. For instance, when we talk about HCl in water, what does it do? It donates its proton. It loses this H ion to water, and we are left with H3O plus and Cl minus, right? So, or you could write this like this: HCl changes to H plus and Cl minus, right? So acids by definition is something that donates a proton, that loses one proton. Proton is hydrogen ion, H plus ion. This H plus ion, if it reacts with water, it would produce H3O plus, right? So that's why when you write, you could rewrite this reaction in this form. So this is how acids behave. Acids donate proton. They lose hydrogen or lose proton. So what would carboxylic acid do? They do the exact same thing. They can also lose a proton. So for instance, right here we have CH3COOH. This hydrogen, which is bonded to the O, hydroxyl group, this can be lost as a proton. So this hydrogen will be donated, it will be lost, water will accept it, it will turn water into H3O plus, and the rest we will be left with CH3COO minus.
Is this process basically neutralizing the acid?
This is in neutralization. We'll talk about neutral. This is when they are acting as an acid.
Okay.
Neutralization is the step where acid reacts with the base to form salt and water.
I see. So for this one, we just said
This reaction is called ionization of an acid. Ionization of acid. Here, acid is breaking into its ions. So it is giving you ethanoate ion and hydronium ion.
so if it loses the hydrogen, would it become more acidic because it loses a positive charge from the.
That's what makes it acid. Reaction is called ionization of carboxylic acid. Here, carboxylic acid is reacting with water and it will donate this proton to water and turn into carboxylate ion. So the name of the acid is carboxylic acid. The name of the ion is called carboxylate ion. Okay. And how do you name this? Basically, if this is ethanoic acid, the ion is called ethanoate. So you replace the ic from the end, you replace this ic acid from the end with O8 ion. 8 ion. So ethanoic would become ethanoate ion. Okay, that's how you name this ion. They lose a proton because 2 oxygen atoms in the carboxylic ion stabilize the negative charge. So this negative ion is stabilized in this structure. So for instance, you could draw this structure like this and it would become like this. So this double bond and this minus charge basically keeps on resonating between these two. So therefore it becomes a very stable ion. Okay, and this is called a carboxylate ion. Okay, so reaction where an acid ionizes in water to produce ions is called ionization of carboxylic acid. These acids are not very strong, they are all weak acids. So all carboxylic acids are weak acids. What that means is they will not completely dissociate to give ions. Some of it will be left over like the original state. Okay, strong acids completely ionize. So when we talk about HCl, it's a strong acid, it will completely dissociate. Everything will dissociate. At the end, you will not have any HCl left. But weak acids do not completely dissociate. Weak acids, if you have a weak acid, assuming this is like a general acid, HA, some of it will dissociate to ions, whereas some of it will stay just like this. So those are weak acids. So carboxylic acids are all weak acids. Okay, for instance, a question, write the balanced chemical equation for dissociation of butanoic acid in water and identify the carboxylate ion. So the question is asking dissociation of butanoic acid in water. Dissociation means another term for ionization. Dissociation means something is dissociating, something is breaking apart, right? Ionization, same thing. Ionization means it is breaking into ions. So they both are basically same, ionization or dissociation. So in this case, we are specifically talking about butanoic acid. Oic acid means it has a perfect, and but means 4 carbons. So one is already here. I'll draw the next one. Let's draw it as a line structure. So 1, 2, 3, 4. So that would be my 4 carbons. 1, 2, 3, 4. Butanoic acid. In water, what would happen? This hydrogen, only this hydrogen is lost. Nothing else can be lost. You can't lose hydrogen from anywhere else. Only this hydrogen from the hydroxyl group will be given to water. And we will be left with H3O plus, double bonded O and O minus. So H3O plus is called the hydronium ion because this is water with hydrogen ion, so it is hydronium ion. And this is called, if this is butanoic You replace the ic with 8, so this will become butanoate ion. Okay, and in general name for this is called carboxylate ion. Okay, so it has to end with 8 at the end. All right, so again to you in next we'll talk about neutralization reaction of carboxylic acid. Neutralization reaction is whenever you add an acid, it reacts with a base to produce salt and water. This reaction is called neutralization. Why is this called neutralization? Acids have a pH less than 7. Okay, so pH, if we talk about pH, acids is less than 7, bases are more than 7. When they react with each other, they produce water, and we know water is of pH 7. So water is neutral. Therefore, this is called a neutralization reaction where acid and base are reacting with each other to produce neutral water. So it's called neutralization. So the first reaction we saw was ionization. Neutralization is whenever acid reacts with base. So this is the same kind of reaction. So the easiest example we'll pick, let's say if we pick some inorganic. So NaOH will react with HCl. How would this react? It has to produce salt and water, right? So water comes from right here. H plus and OH minus will react with each other to produce H2O, and rest we are left with Na plus and Cl minus, so they will form a salt, NaCl plus H2O. Same thing we'll do with carboxylic acid. Okay, now let's pick our example. So what do we have here? We have methanoic acid, which is C double bond O OH. So this is acid. NaOH is our base, so this OH from the base and hydrogen from the acid would react to produce H2O, HOH, which is H2O, and what's left will join it together, which would be Na plus from here and HCOO minus from here. They will join with each other to form a salt. You don't have to include these signs. You could simply write this as HCOONA. That would work as well. Okay, this is just showing you that this is now a salt, or you could simply write this as HCOONA. That would also work. Okay, so what would be this? This is now a salt. How do we name salt? We use the name of the ion. For instance, how we name this salt? We call this sodium. So you put the name of the cation followed by name of the anion, sodium chloride. How do we name this salt? Same approach. You name the cation, which is Na plus, so it is sodium. Then you name the anion. What is our anion? HCOO minus. What is the name of this ion? That's a common name, carboxylate. But if I'm talking about the specific name, so this is called methanoic acid. So the ion would be called, you replace the ic acid with 8. Perfect. So it would be methanoate. So name would be sodium methanoate. Okay. So this is called neutralization reaction, when acid reacts with base to produce salt and water. That never changes. It's always salt and water. Okay. So how would a question look like? Instead of methanoic acid, we could give you any other acid, and we'll ask you what would be the products from neutralization of this reaction. So you should know what is a neutralization reaction. Neutralization would be acid reacting with base to make salt and water. Okay. And this is already, I explained this to you, that the carboxylate ion is named by replacing ic with 8. So for instance, if this is benzoic acid, the ion which is produced would be called benzoate, right? And this is a neutralization reaction. This is acid, this is a base, which is KOH. So hydroxy from here and hydrogen from here will form water, and rest everything else will join with each other. You don't have to show these charges. You could simply write this as potassium benzoate, which would be C double bond O O K. That would do. Okay. Okay, let's try this question. Write the balanced chemical equation for the reaction of propanoic acid with NaOH. Okay, so what is the reaction between propanoic acid, which means this is an acid, reacting with NaOH, which is a base. So this is a neutralization reaction. Acid base will react to produce salt and water. So let's write our reaction. Propanoic acid is 3 carbon acid, so I draw 3 carbons. One of these carbon has to be COOH. The rest we fill up with hydrogen. This has 2 already, 2 more. This has 1, so it needs 3 more. This would react with NaOH. How? This hydrogen and this hydroxy will produce water, HOH. The rest will produce the salt. So we would have CH3, CH2, C double bond O, O and A. That is our salt. So this is water. Let's name our salt. This was propanoic acid. So this will be called name of the cation. We always put name of the cation. If you can't remember, just whenever you see salt, think of sodium chloride, NaCl. So always sodium comes first. We name the cation first. So this would be propanoate. Perfect. And anion here is oic. We replace the ic with 8. So propanoate. And of course there would be a space between here. So sodium propanoate. Okay. Alright. Okay, we'll start with esters then. So esters is the next functional group. Again, this consists of, this is another derivative, you could say, of carbonyl. So this has the carbonyl group, and carbonyl has 2 more groups. So out of those, one is an R, the other one is the OR. That makes it an ester. Okay. How are they synthesized? These are synthesized from reaction of carboxylic acid with an alcohol. Okay. So carboxylic acid reacts with alcohol to produce ester.
So it's a weak acid with an alcohol.
With an alcohol.
So it's like kind of neutralized then? Because when an acid and alcohols don't mix too, or?
No. Neutralization is again when acid react with a base.
Base, right.
Alcohol is not a base.
Alright.
So whenever acids, so right now we saw couple reactions before where when alcohols were reacting with aldehyde, aldehyde were reacting with alcohols to produce hemiacetal and acetal, right? And now carboxylic acid, when carboxylic acid reacts with alcohol, it produces ester. Okay, and this reaction is called esterification. Esterification. Why? Because this is a reaction for production of esters or synthesis of ester. Therefore, the reaction is called esterification. Okay, this esters, basically, where would you find those? These are also some aromatic compounds. No, that's a wrong term. I shouldn't say they are aromatic compounds. Aromatic have benzene. They are the compounds that have aroma. They also have aroma. So they add aroma and flavor to compounds. For instance, bananas, oranges, strawberry, all the flavor that you, or the odor, or kind of the smell that you get from bananas, oranges, that is because of esters in them. Okay. For instance, let's see how they produce. What is this reaction? How would you produce an ester? So this is the reaction. We have an acid, which is COOH, ethanoic acid. Then we have an alcohol, which is CH3OH. How would they react here? In this case, water will be lost, this hydrogen from the alcohol and OH from the carboxylate group is going to react with each other to produce HOH, which is water. So water will be lost, and the rest, whatever is left, you join it together. That's it. So this CH3CO joins with OCH3, and this is now an ester. So you can see this is your carbon, COO carbon. So that is RCOOR. So this is the ester that is produced. So this water is lost as water, and rest everything else is joined together, and this is now called the ester. And therefore this reaction is called the esterification reaction.
For naming, it would be the same.
For what?
For naming?
Naming, yeah. Let's name it. So how would you name an ester? Naming is a little different, okay? When we name an ester, you can basically split the molecule right here. So the part, you can split the molecule after the COO group, you can split the molecule. So both of those would be named separately. We would name this separately. This is coming from the carboxylic acid. So count this carbon in, this is 1 carbon, 2 carbon. What was the name of this acid component? If this was the acid, COO minus, right? What would we call this? Ethanoate. This is carboxylate, right? So 2 carbon carboxylate ending with 8, so this becomes ethanoate. And what is this group? This group is named as the alkyl chain. So 1 carbon alkyl is called methyl. So this is called methyl ethanoate. Okay. So you simply name the part that is coming from alcohol, that is called the alkyl, and the part that is coming from the acid would become your carboxylate ion. So how would you name it? You simply break, when you see this compound, first thing you recognize this is an ester. How do you name ester? You break the compound right after COO group. Everything after the COO group is alkyl. Everything that includes the COO group, that chain becomes your acid, carboxylate ion. Okay. Other examples, for instance, right here, the question could be as simple. Can you write what would be the product produced from reaction of ethanoic acid with propanol? Okay, so first thing you need to recognize, what is this reaction? This is acid reacting with alcohol. Acid with alcohol is ester, esterification. It would produce an ester. So we write this reaction. Let's do it ourselves. So if we are doing ethanoic acid, that would be 2 carbon, one of those carbons would be COOH, and then this already has 4 bonds, this would have 3 hydrogens. So that is ethanoic acid. We are reacting it with propanol. It says 1 propanol. So prop means 3 carbons, and one of those carbon has alcohol. It says 1, so I would assume I'll take this as 1 carbon, number 1. Okay. Rest we fill it up with hydrogen. So this carbon already has 2 bonds, so it needs 2 more. This carbon has 2 more. This carbon has 1, 3 more. So that is our propanol. How would they react? Remember, the carboxylic acid gives the OH and the hydrogen comes from the alcohol. So this will be lost as water, and rest everything else we join. So let's join it. This would be CH3, C double bond O, O, CH2, CH2, CH3. Okay. Now if we were to name this, how do we name it? Remember, when you're naming an ester, where do we put the break? Right around here. Right after the COO group, we put a break. Whatever is part of the acid, carbonyl, that becomes your later name. That is your carboxylate ion. So what would be the name of this? This is 2 carbon. 2 carbon is ethanoate. Perfect. So this would be ethanoate. And then we have this, which is an alkyl chain. How many carbon is it? 3 carbon. 3 carbon is propyl. Perfect. So the name would be propyl ethanoate. Okay. One important thing here is, for instance, we saw aldehyde is Al, alcohol is Ol, acid was oic acid. Those are fairly easy to remember, but esters have, this name is very different. It doesn't tell you this name is an ester. This is the only place where you kind of need to remember whenever you see an alkyl with a carboxylate ion. So how I remember it is alkyl with carboxylate. This, whenever you see this name, this is name of an ester. Alkyl carboxylate, if you see, that's an ester.
Alkyl was the
Okay, so we this again, the answers are also in the slides. So the name of the ester consists of two words. The first word indicates the alkyl part of the alcohol, the part that comes from the alcohol. Like we saw, we break this right here after the carboxyl group. The second word is the carboxylate, which is name of the carboxylate acid ion. So if you're naming this, what would be the name? This we break right here. This is called the alkyl group, which is methyl, and this part right here is part of the acid, which is the carboxylate. How many carbon? 1, 2, so ethanoate. So this is methyl ethanoate. Okay. For instance, let's name this compound right here. Don't look at the names yet, try to name them yourself. First thing you should always see when you see organic compound is identify what functional group you see. Because you are seeing here chapter by chapter, so it looks like easy. But when you're seeing bunch of compounds together, first step is you have to recognize, okay, this is an acid, this is an ester. Okay, so first step, always do that. So in this case, I'm recognizing this is COOR, which means this is ester. So we break the ester right here. This becomes my alkyl, which comes first. What is this alkyl group? 1, 2, perfect, 2 carbons, so it is ethyl. And then this is my carboxylate, which is also how many carbons? 1, 2, so this is ethanoate. Ethyl ethanoate. Okay, let's name this. This is again an ester, RCOOR, ester. So we break the compound right here. This becomes my alkyl, which is methyl, and this becomes my carboxylate, which is 1, 2, 3 carbon. Don't forget to count this carbon in. This should be counted in. 3 means propanoate. If it was acid, it would be propanoic. If it is carboxylate, it would be propanoate. That's how you could memorize it. So if you can't simply think of propanoate by itself, you think this is 3 carbon is propane. You replace the E with oic, then you replace the ic with ate. So propanoate. Okay, those are the steps that would get you to this propanoate ion. Next, we look at this compound. When you look at this, you see a benzene, then you see a functional group which is COOR, which means it's ester. So we break it right here. This is my alkyl, which is perfect, 2 carbons, so this is ethyl, and then I see carboxylate ion, which acid is this? This was benzoic acid. So the ion would be benzoate. So ethyl benzoate. Okay. All right. Named already. You could see some more examples right here. For instance, let's try to name this IUPAC compound. Again, it's an ester. Break right here. Propyl. Perfect, propyl ethanoate. Good, this is 2 carbon, 1, 2, so it is ethanoate. Okay, now the question is, draw the condensed structure formula for the following compounds. Condensed is when you show carbon bonds, but you don't show the carbon-hydrogen bond. Okay, so the question is 3-bromobutanoic acid. So first thing I see oic acid, so this is COOH. Which carbon? 4 carbon. So I draw 4 carbon, 1, 2, 3, 4. 4 carbon, oic acid means it has to have a COOH group, and it says it's 3 bromo, so I start numbering 1, 2, 3, which means this has to have the bromo. So 3 bromobutanoic acid, perfect. Now I fill in the hydrogens. So this carbon, 1, 2, 3, 4, already has 4 bonds, no more. So this would be 3 bromo. Next we are filling the hydrogen, so no hydrogen. This carbon has 2, so needs 2 more. This carbon has 3 already, so needs 1 more. This carbon has 1, so needs 3 more. Perfect. So that is 3 bromobutanoic acid. Okay. Next we see ethyl propanoate. Remember, this is the only one that does not really give you an indication that this is what function group it is. So when you see any alkyl with a carboxylate, that's an ester. So how do we draw this? Again, start from the very end. Ester, which is propanoate. So I will draw my propanoate ion, 1, 2, 3 carbons. Propanoate means this, right? COO. Then it is ethyl, so you draw the ethyl. C, H will add at the end, so 1 carbon, 2 carbons. That is my ethyl propanoate. Now let's put in the hydrogens. Okay, so how many hydrogens? This needs 3 more, it has 1. This has 2 more, so it needs 2 more. Then it's oxygen. Oxygen has 2 bonds. This oxygen has 2 bonds. This carbon has 4 bonds, so we don't add anything else. This carbon has 2, so needs 2 more. This carbon has 1, so needs 3 more. Now you can also confirm that if you were naming this, you break it right here. This would be ethyl, this would be 1, 2, 3 propanoate. So that would be your structure for ester. Okay. Then we come to some reactions that esters undergo. Okay, so esters will undergo hydrolysis reaction in presence of acid or in presence of base. What is hydrolysis? Hydrolysis is lysis in presence of hydro. Hydro means water, lysis means breaking. So ester is going to break down in presence of water. Which water? Acid water. Okay, so acid water means there is presence of acid in this compound. Okay, so this is breaking of ester. What would ester break into? How was ester produced? Ester was produced from alcohol, acid reacted together. So when it breaks, it will produce alcohol and acid. It's basically opposite of esterification.
This is reversing the process.
Yeah, this is reverse of the process. Only important thing here is you have to keep an eye out. Is it acid or base? That would make a difference. Okay, so let's see how that makes a difference. So this is my ester example. This is methyl ethanoate. So CH3COO CH3. So I see this is an ester. In presence of water, water is HOH. What do we want to produce? We want to produce a carboxylic acid and alcohol, right? How would we break this? So remember, you're just doing the opposite. So what did we do there? We broke it right here. This will become the alcohol. This, whatever has the carbonyl, will become the carboxylic acid. So this will break and it will interact with hydrogen, and this OH will react with this carbon. Okay, so this would become CH3OH, which is alcohol, and rest becomes CH3C double bond OH, which is our acid. Okay, so you're basically just doing the exact opposite. It will only be helpful if you kind of like remember esters on hydrolysis produce acid and alcohol. How do you remember it? You have to remember esters. How are they produced? Esters are produced by carboxylic acid alcohol. When you're breaking it, it's opposite.
You said it breaks down in the presence of the acid.
This is in presence of acid. So acid you would see right here, H plus and heat. So sometimes the reaction might not directly tell you this is hydrolysis hydrolysis. It would just give you this reaction. There is water, it would give you H plus and heat. You just have to automatically understand that this is acid in presence of water. It means this is hydrolysis in presence of acid. Okay, so in presence of acid, this is what it would produce. Acid will stay as acid and alcohol. Okay, but now what happens if I do in presence of a base? Hydrolysis in presence of base. So same reactant, right? We have acid portion here, and then the rest is the alcohol portion, right? It would react with base. Base is NaOH. How would it react? Basically this would become CH3OH. This would get the H from here, right? So this and the hydrogen are going to react with each other to form the alcohol, because that's one of the component. Rest, instead of this becoming a carboxylic acid, this will react with NaO to produce the carboxylate ion or the salt with sodium. Okay, so in presence of base, the NaO is going to react with this CO or the carbonyl group, and you would have the salt produced. Okay, so in this case the product would be salt and alcohol, and this salt actually is an example of a soap. This is what soap looks like. If you talk about the soap, basically means the normal soap that we use, dishwasher or detergent, all those are somewhat derivatives of this. So it basically consists of a carboxylate with a salt, and this soap is, because this reaction produces soap, it is also called as saponification.
So for the base hydrolysis, the products are always going to be
Alcohol and salt. So it is still breaking the molecule, it is still hydrolyzing, but because there is base present, the base further reacts with the acid and it produces salt. Okay, so if you can't remember it in this way, you could also think it that this is also hydrolysis. So you first break this into salt, not salt, you break this into alcohol and acid, which would be COOH, and then acid can react with base. Remember, acid base neutralizes to produce salt, so it would finally produce salt. So it is like a two-step reaction, right? But it is basically the same thing is happening here. Ester is breaking to form acid and alcohol, but then acid is further reacting with the base. Okay, so that is the reaction of hydrolysis of ester in presence of base. And this process is called saponification because what it produces is actually an example of soap. For instance, write the balanced chemical equation when methyl ethanoate reacts with water, heat and an acid catalyst. So when you look at this, you see methyl ethanoate, which means this is ester, is reacting with water in presence of heat and acid, which means this is acid hydrolysis. So we draw the structure. Let's draw methyl ethanoate. So we start from the end, which is ethanoate, which is 2 carbon. It's OH, which means this is the acid, right? And then we have the alkyl group, which is methyl, so 1 more carbon. Let's fill up the hydrogen. So this would be CH3. This carbon already has all 4 bonds, so we are okay. This carbon has 1, so it needs 3 more. Now this would react with water. Perfect. H2O. And H2O you could write it as H2O or you could write HOH. How would HOH react? Again, we break the compound right here. Oh, right here. Right here. This would be a cut. And what happens? This gets the hydrogen and it would turn into alcohol. So this would become CH3OH, right? And the rest is the OH would get to this other rest of the molecule, which is CH3C double bond OH. So that would be our acid. This would be ethanoic acid, and this would be methanol. How could you remember this? When you see the name methyl ethanoate, ethanoate will turn into ethanoic acid, methyl will turn into methanol. Okay. Now, how would this react in presence of KOH and heat? KOH means this is base. So now we have CH3, C double bond O, OCH3 will react with KOH. How would you break this? Again, this has to make the alcohol, so it needs one hydrogen, which comes from this. So it would form again CH3OH right here, and rest everything else that is left will join together. So it would become CH3, C double bond O, OK. So these are the two components. Now what is this called? This is still methanol, and this is which ethanoate? Potassium. Perfect. So this is potassium ethanoate. So again, this ethanoate will become salt with potassium or your base, and this would turn into alcohol. Okay, so that is hydrolysis of an ester, which is basically opposite of esterification. And I think that's it. The explanation is again given to you in the slide as well, and that is all about carboxylic acids and ester.